Hello guys, welcome to my YouTube channel. So today we are going to look into the data structures and algorithms roadmap. I have listed a few things that we can go through so that once you are prepared for this, it's very much easy to crack any kind of product-based companies or whatever it is. Okay. So usually in a software development role, the first round would be data structures and algorithms role, where you have to solve the assignments from the listed topics here. The second thing will be system design. Few companies have high-level design, few companies have a low-level design, few companies have both. Okay, so that comes to be the second round, and whether the third round is regular HR round. Okay, um, this is a roadmap where we will be concentrating on what are all the topics that we have to study, how do we get started, and what are all the things that into this uh, a thing called as data structures and algorithms under each and every category. For example, graphs, what are all the things that you have to cover under? We'll go over this particular roadmap. Once we complete this, you will have a clear-cut understanding on what are all the topics that are actually present. Okay. So, um, the first step, okay, as you see here, I have listed these things, right? Let's get started. The first thing is to choose a programming language. Okay. Programming language. Usually, in the world of data structures and algorithms, the most three used programming languages are Python, C++, and Java. Okay. Out of these three, my personal preference would be to go with Java. Even though I have practiced the data structures and algorithms with C++, I would suggest you to go with Java. I will tell a reason behind, okay? So in terms of which is the fastest language, the language that is fastest is C++, next is Java, next is Python. When you see some computer hardware drivers and all, mostly they are all written in C++, some kind of networking, like networking companies like working on 5G, 4G, they all use C++. That is because the language is much faster compared to anything else. So the second thing is Java. Okay, this Java is a little slower compared to C++, but it has its own advantages. Okay, then comes Python, usually used in the data science industry. Once usually teams in artificial intelligence, what they do is they do the POC in Python, so they get to implement their applications also with Django or Flask, whatever it is. Okay, so what do you choose between these three? I would suggest to go with Java because once you prepare this data structures and algorithms, when you move to system design, it's much more easier. When you follow any course, they will be discussing things mostly in Java. Okay, that will be the first preference. Also, with Java, it is much easier to understand low-level design coding because there are some certain keywords very well defined in Java, so it is much better to go with Java. That being the first reason. The second reason to go with Java is uh, the second reason that you have to go with Java is that it is kind of a language. When you are very well prepared with this language, tomorrow you get into a company, wanted to develop some applications. So in that case, you are already pretty much comfortable with the language Java, and just we have to learn a framework like a Spring or something else to understand the complete development. But when it comes to C++, there are not very famous libraries or frameworks where you could just develop applications. There might be few, but in industries, mostly Java is preferred. So that is why I suggest you to go with Java. Okay, the keywords, everything is all very clear. Also, of course, there are languages like JavaScript and few other things, but they all have their own purpose. Into DSA, I'm not sure. They don't come much into this. Okay, so here I have listed the topics that we have to cover. Okay, the first thing is time and space complexity. Okay, what is time and space complexity? When a program executes, okay, how do you know this is the time this program taken to execute, and how do you measure them? Same way for space as well. How do you measure them? Okay, for example, I have a simple for loop. Uh, Assume I have created an array. Okay, this array must be taking some space in my memory, right? How do you calculate that? We calculate until this is of order of n space. This array has captured order of n space in my memory. This O stands for order, which means worst case of n. Okay. When you talk about time and space complexity, you have to always talk about the worst case. What do I mean by a worst case? Okay. So Let me take up a simple example. Okay, I have to mm, I have an array. Okay, where the I have some numbers 1, 2, 3, 4, 5, 6. Okay, I have these numbers like this. So inside these numbers, I'm going to stand here and check my problem statement is that I have to check if this array contains only sorted data. So one approach that I can do is I can place a variable or a pointer here. Then this is one. Okay, the next value that I'm seeing should be greater than one. Only then it is a sorted array. So in that case, what you could do is one. Then you check 2, 3, 4, 5, 6. Okay. One time I checked for one. Okay, which took order of n space. Next, what I'm going to do is so for one, I have checked all these elements one by one. So what happened is I have put a loop where for one I have done n traversals. Okay, n number of traversal. For one, I have traversed through whole array and checked if everything is greater than one to see if the array is actually sorted. The next thing that I had to do is move to the next variable 2. Once again from here, what I will do is I will go iterate over this, check if everything is greater than 2, 3, 4, 5, 6. So what happens is I have to move to each and every number one by one, and then I have to do a traversal. So basically what happens is if you have n numbers here, then I'm taking n, I'm making n square operations, which means n square operations. Okay. So at the worst case, this algorithm takes a time order of n square. Okay. Same way, let's take the same question to check if the array is sorted. Okay. 5, 6. Okay. Now what I'm going to do is check. Put a variable here, store it in 1, then move to 2. Okay. 2. Okay. 3. Yes, 3 is greater than 1 and 2. Okay. Move forward. 4. Same way till 6. So what happens is I have traversed the array only once, which takes this time complexity to be order of n. Okay. When space complexity, this array is basically has taken order of n space. Okay. Any data structure that you declare mostly would take order of n space. But in terms of recursion, the space that it occupies is a little different, but not very different from the actual thing. So the first thing that you had to understand is time and space complexity. We always represent it in order of 1, order of n, then order of log n. There are a lot of terminologies to represent things, and also this O means worst case. Okay, to represent average case, we have something. To represent best case, there are some different things. But usually in programming, we represent it by order of n. When an interviewer comes and asks you what's the time complexity of this program, then you have to tell it order of n or whatever it is in or worst case scenario. Okay. Once you are very much familiar with this time and space complexity, before coming to this time and space complexity, you must be clear with all the basic loops and all. You have to be clear with loops, if statements, basic stuff like declare a simple array, 1D array, and put some values into it, shift those values. Those things you must be clear before coming here. Okay. So once you get to complete this time and space complexity, the next thing that you have to focus is on the general algorithms. General algorithms are nothing but the typical mathematics and kind of an intuition that you have to build before going into something much difficult. Okay. So general algorithms means there are a little more. I have not listed everything here. So if you see, the first is even odd logic. Okay, something like a number mod 2 is equal to 0, which means this will tell that the number is an even number. If it is 1, this is an odd number. So this kind of logics. First is the number of even odd logic. Next is number reversal. For example, 321 is a number given. How do you turn it to 123? Okay, with the least time complexity. Okay, so that is there are some simple formulas like 1 into 10 plus 3. These are all number system stuff that you must be learning in mathematics in young ages, else you will have covered it in digital logic design in your engineering days. Okay, next is the GCD and HCF stuffs. Simple, the mathematical stuff, GCD and HCF. So there are some typical algorithms for this. Next is prime numbers. How do you print the prime numbers? Usually, prime numbers, there are multiple methods. Actually, there are something called as a uh, I don't get the name immediately. Okay, there is something, there is a method where you declare an array, do something like this, go in multiples of that specific number and do stuff. Okay, that is one approach, and generally just to iterate from one to whatever the hundred is, whatever the range it is, you put some logic inside and find the print prime numbers and print them. Okay, these are all the different general algorithms that you have to first learn them. And after doing this, the next thing that you have to do is patterns. Printing different patterns. For example, print a triangle using star. How would you do that? So what happens is when you learn this pattern printing and everything, you will get to understand um, how to actually use the loops, how those loops works actually. So all of them, you will have a very clear-cut understanding on completing these patterns. There are a lot of pattern questions that you have to finish. After this, the next thing that comes is basic recursion. Okay, basic recursion. I'm not meaning like a recursion with a grid or something like that. I mean a basic recursion. Okay, which means you first need to know what is recursion, what is head recursion, what is tailed recursion. You need to know all of them. Okay, once you finish them, once this is all kind of a theoretical concept. Once you finish them, you have to understand what is a base class in a recursion. Base class, sorry, base condition. Sorry, what is a base condition in a recursion, and how do you write those base condition? In recursion, if you see, base condition is the very important thing. Else, what happens is it will just keep going recursing back again and again and again, and you will exhaust your memory. Basically, it will cause an error. Okay, so you have to understand how to write basic recursion with proper base condition, how to write all of them. Okay. Printing stuffs in the sense, I mean, like printing 1 to n, you have to start like that, printing 1 to 1 in a recursive way. Usually, how you will do, you will just declare a is equal to 1, then you will just do some for I is equal to 1 to till 10, you just do print. So, this is what you would do, right? But in case of a recursion, you will be taking this a as a parameter, okay, and n is the limit. So, this is going to be a function which will have a base condition if a is equal to n return something like that. This is the base condition. Then you will just write some uh, recursive questions, recursive statements here to get them printed. Okay, so you have to understand basic recursion. Next is hashing. What is hashing? To retrieve the data very quickly. Okay, instead of in case of an array, for example, I have to check there is a number called as 7 or not. What I would do, I will just iterate over each and every element and check if 7 is present. So the time complexity at worst case is 7. Okay, but to reduce this, what do you do actually? You have to know what is hashing. Okay, with hashing, you have to understand what is collisions. For example, hashing is basically something like a number. Okay, not a number. Let me take a user input. Okay, that's coming in. That's coming in. Okay, so I apply some hash algorithm on this and I put it in my memory. So in the next time the user comes and asks me some number, what I will do is I will do the same hash algorithm. Go check if the data is present. This is what hashing means. Okay. So here you have to understand what is collision. Collision, all that is not being asked in interviews, but still it is very essential that you need to know what is collision, what is probing. There are different types of probing techniques like quadratic probing, polynomial probing. You need to understand all of them. Okay. Once you understand this, this is the basic stuff you need to have. So once you are good with this, no sorting also. Okay. So once you are good till this, you are prepared for any kind of TCS, Wipro kind of companies, okay, uh, and also a fewer number of good companies as well, okay. So next is the sorting techniques. What are the sorting techniques? Merge sort, one of the most important sorting technique because it has the least time complexity in most of the cases. Also, this merge sort, what happens is being used in other problems as well. For example, you have to use it in kind of a matrix thing. There are binary search, linked list where you have to merge stuff. So you have to relate to this merge sort algorithm and you have to build an algorithm for that specific data structure. That is where you have to understand the sorting algorithms. Merge sort is important. It is very much important to understand the time complexity, space complexity of merge sort, selection sort, all of them. Next is selection sort, bubble sort. I usually remember this as bubble by bubble sorting. Next is insertion sort, count sort, radix sort. These two are not much important, but still good to know. Next is quick sort. This is one more sorting algorithm. So you have to understand the time complexity, how it all works like. Okay. Usually, we don't go and implement this merge sort exactly or any sorting algorithm. In companies and productions, when you are working in a development project, you just put a sort what it will just sort and return it. Okay, that is done in the development phase. But in interviews, you are expected to actually implement this data algorithms. Okay, but if the question is going to be something a little different, and there you have to do some sorting, you can just write some custom functions or instead use the inbuilt function. But the question itself, if it's going to target on the sorting, then you have to go with uh, this merge sort. You have to go with the complete implementation. Okay, till this you have to be very clear. This is kind of a basic everyone needs to know. Okay, without this, it's very hard. Next is even arrays is very important. Okay, next is arrays. You have to understand 1D arrays and 2D arrays. 2D arrays are nothing but matrices. Okay, so matrices. You have to understand simple rotation, rotate an array by this leaders. There are some problems like leaders in an array. There are a lot of such questions. Okay, next is longest subarray sum, Kadani's algorithm, prefix and suffix algorithm, scanline algorithm. There are a lot of things that you need to understand. Uh, stock problem. This is basically a stack-based problem, but you could still solve it with arrays with little more time. Okay, so you have to understand them. Then there are questions that are related to arrays and merge sort combined together. You have to learn them to complete arrays. Okay, arrays itself is a very simple data structure, but the questions that's going to come in is also going to be most probably simple, but it's about the thinking intuition that you have built through problem solving. Okay, next is linked list. There are different types of linked lists, right? Singly linked list, doubly linked list, circular linked list. Actually, the most important algorithm or the most frequent algorithm that comes in this linked list is fast and slow pointer. Once you are familiar with this algorithm, you will be able to solve most of the questions. Nothing but most of the questions. The This algorithm first, where do we use this to find the middle of a linked list? How do you usually find? First, go iterate the complete linked list, find the length, then go to the middle and stop there. That is what you would do, right? Instead, if you use a fast and slow pointer approach, just with one traversal, you will be able to do. You will have the fast pointer at the first both the pointers at the first stage. Then you will move the fast pointer by 2 points and slow pointer by 1 point. So what happens is, uh, by the time this fast pointer reaches the end of the array, it is a law that the slow pointer will be at the middle of the array. Okay, middle of the linked list. So that is one among the important algorithms. You have to understand in circular arrays how is the base condition. Base condition in the sense like how do you find out the start and end of a what do you say, start and in a singly linked list, you will say this is the head and this is the title. In a doubly linked list, it's a little complicated since we have the previous one. But in circular, how do you say this is head and this is title? It's going to be completely circular. So you have to understand the conditions that's there. Okay. And linked list itself, you can implement with arrays. So there are different types of implementation that you have to learn. Next is sliding window on 2 pointers. One of the most important thing that you will see in many interviews. If it is going to be a basic company, it's going to be a decent normal company, then you will see this algorithm coming up, sliding window and 2 pointers. Very important. Okay. Next is again recursion. Okay. When comes to recursion again, here I'm talking about the difficult part of the recursion, which means not a difficult part, which means the exhaustive part of the recursion, where you have to deal with many matrices. You have to deal with multiple boundary cases to make sure the ends are properly matched. Basically, writing good base conditions. Once you are very clear with this particular basic recursion, only then you will be able to come here and understand how do you actually write a tree, how do you actually understand things to learn them better. Okay, so okay, so next is arrays is fine. This is fine. This is completed. Next is strings. Okay, one of the important thing. There are a lot of algorithms inside like KMT, longest common subsequence. There are a lot of them. You have to finish strings next. I should have put it little up even before arrays or after arrays. This also comes in. There are some difficult things with strings. There are some much easier things with strings. Basically, string questions you have to practice a lot. In terms of the thinking, it's very easy, but when you have to go and actually implement it, You have to know how do you make a character a capital, maybe what does this particular thing mean. So you need to know all of that. Okay. So strings. Next is binary search. The primary idea behind binary search is it can be applied only when the array is sorted. So the input that's going to come inside is not going to be always sorted, right? So how do you handle that? You have to work by so you have to work by uh, making some kind of a you have to understand how to fix a search range within the particular range. Once you master this particular thing, what is finding the search space, then this binary search problems are going to be very easy. So some of the very famous and familiar problems are aggressive gauss painter's partition, searching in a 2D matrix, matrix median. These are all some kind of most frequently asked questions when it comes to DSA. Okay. Next is so Next is bit manipulation, not asked in most interviews, but there are certain concepts that you need to know. For example, there is XOR concept which you definitely need to know. For example, there is a question called as find out the missing element from this particular number. What do you do? Or find out the one element that repeats only once and all the element that repeats twice. How do you find that one element that occurs only once? So what you can basically do is XOR all the elements in the array. What it will happen? What will it happen? This it will just get me the what do you say? It will just give me the one element that occurs only once because of the property it has. So you have to be very familiar with XOR property, all of them. There are little more things like how do you set a last bit, how do you set a particular bit, how do you check if this particular bit is set or not. You have to learn all of them. Important, but not to a greater extent. Okay. Next is stacks and queues. So stacks and queues, what happens is usually people will come solve these questions like next greater element, trapping rainwater. These are all famous questions. People will start solving them. But when it comes to prefix, suffix, postfix, infix, the thing is they will end up losing. They will not most they will not cover this. They will miss out this because but this is all covered in portions like gate examinations where you will become very comfortable actually doing the algorithm with your pen and paper. It is very important that you actually cover this, even though if it is not asked in interviews, but it's very much, it will help you understand the data structure very clearly. How practically you could use it. Okay, prefix and infix, it's very much important one, which people tend to lose it. Next is like general, next greater heap and the trapping rainwater problem. This is all general ones. Okay. Next is stock spin, LFU, different caching algorithms. LFU stands for least frequently used algorithm, and LRU stands for recently used cache. Okay. Next is heaps. There are two types of heaps: min heap and max heap. You need to know the complete understanding of min heap and max heap. Just like that, declaring a priority queue, making it a max heap or a primary heap with the primary max or a min heap with a greater keyword doesn't help. Okay, you have to understand the implementation. Heap is an interesting concept once you understand. Okay, so you have to understand this. Once you are familiar with this, you can. This is very much necessary. Okay. Next is greedy algorithms. Okay. So this is one topic where you have to concentrate more because concentrate more. Why? Because, for example, in greedy algorithms, generally when you see a question, there will be two options. Okay. Uh, in the next choices, just an example. Okay. In the next choices, pick the most optimal one, and finally you will assume that this particular end result will be good. But ultimately, that problem will want you to do all sort of method using recursion. So you need to be in a position to figure out either to use greedy algorithms or dynamic programming or recursion. Okay. So in this case, what you have to do is you have to be very clear with greedy algorithms. There are some certain specific questions like knapsack, job scheduling, Huffman encoding, all of them. Once you are very clear with all of them, it's very easy to identify the questions. Okay. Next is binary trees and binary search trees. Okay. So what happens with binary trees is that, yes. So what happens with binary trees? You have to understand the principle and the actual logic behind binary trees and binary search trees, how they are actually different with the implementation. What are balanced binary search trees? You have to understand all of them. The first thing is recursive way of actually traversing a particular tree, and another way is to actually traverse a tree based on the iterative algorithm. Okay, iterative algorithm. So there are two methods. You have to master both of them too. Once you master that, right, and there are some specific questions like what is the diameter of a tree, what is a how to print the leaf nodes of a tree. All this will be a little easy to understand. So the very important thing with this, with trees, is that you understand the actual implementation of traversal techniques. Okay, there are three traversal techniques. One is in order, pre-order, poster, and there are a few more like breadth first traversal, and there are a little bit like um, few more, and there is one more traversal technique that is called as level order traversal. You have to learn all of them. Next is graphs, one of the most favorite topic of mine. Okay, because like uh, once you understand this DFS, BFS topos right, you will feel like, yeah, how do you go and actually implement this thing? But what happens is once you actually start solving questions in graphs, it will be very interesting because the questions are like that way. Okay, for example, you know DFS, right? There is a question called a surround region. So I have to find the island. Assume one is water, sorry, one is land and zero is water. Okay, so I have to find specific islands in this particular graph. Okay, so what I will do is I will first go and hit the one, do DFS from one to check all the ones that is inside the matrix. So what happens is I will change all the values inside the matrix, and then I will be left out with only islands which are not able to be, which we could not reach from the boundaries of the matrix. Okay, so you have to learn this depth first search, breadth first search. It is very much necessary. There are different applications to it. Next is the topological sorting. In topological sorting itself, we do it with one more thing called as Kahn's algorithm. Basically, a BFS way of doing topological sort. Okay, we will just calculate some integers, find out, put them in the queue. All that we will be doing. Then Dijkstra and Kruskal for putting Dijkstra and Kruskal to find out the shortest path. All of them, we use them. Kruskal, this is little, I won't say little difficult, but you have to understand a specific concept called as um, I don't exactly get that name. Okay, there is a specific concept that you have to master. Some kind of we will declare a rank, and then we will declare we will find out the rank. So basically, Kruskal, the time complexity we are reducing it, right? So anytime I must be in a solution to tell uh, if there are two components of a graph, I have to tell in order of one time if these two components are connected or not. If I have to do it with some other algorithm, it will take a lot of time. Minimum spanning tree, it will take a lot of time. But with Kruskal, we could use that specific algorithm, and then you can finish it off very quickly. Okay, next is tries. Okay. Uh, Most of the questions from tries you will have an opportunity to solve with some other algorithm, but the data structure, but the time complexity will be very high, so you have to understand tries as well. Basically, like it's kind of a graph of maps, okay, used in uh, mostly used to solve string kind of questions. Next is dynamic programming. You know, dynamic programming. Like when you do recursion, what happens is there are a lot of again and again redundant computations that's happening. Okay, to reduce this computation, what we will do is first we will take the values, okay, from the particular computation. Whenever the specific computation is done, we will go and store it in a matrix or an array. And then when the same computation comes again, I will just pick the value and serve the value instead of actually making the computation, making the time smaller. So this is going to be, there are different things like tabulation, memorization that comes in dynamic programming. So once you master all of them, you will be able to optimize the code to a very lowest level. Okay, basically dynamic programming has to start with recursion, then it goes to tabulation, then it goes to memorization. Then it will people will use different names, memorization, everything same. Okay, then you have to create a, what do you say? Finally, you have to reduce that space complexity of that space complexity of that specific algorithm. Okay, finally, it boils up to a very lowest space and lowest time. That is the target of dynamic programming, reducing the time complexity. Okay. Next is segment is rarely asked in interviews, not very frequently asked. So you have to cover this as well. So once it is very much important you at least cover this before you attend some top-notch companies. So thank you. Subscribe to my channel. So let's meet again in the next video. Thank you. Bye.